Hello, my name is Bernard Lucien Liu. In this presentation, I would like to discuss the operationalization of codified knowledge from an economic and computational perspective. The result of this operationalization is Mathematica code, function definition, that will run a simulation of knowledge contagion in an emergent destination. Much of the coding is derived from Gaylord and Nishadate, 1996. I have therefore entitled this presentation, From Codified Knowledge to Mathematica Code. This program of reducing our objective reality into lines of code is a recurrent theme in the works of mathematicians and physicists. To name a few, Alan Turing, von Neumann, Ed Fredkin, Stephen Wolfram and Seth Lloyd. The computational S that emerges out of the codification of knowledge is essentially an algorithmic destination that has changing dimensions in space and time. This presentation outlines the research design considerations for such algorithmic destinations. I begin with the premise that knowledge is the driver of economic competitiveness. Regardless of whether this competitiveness references the organizational level, regional or global level. By now, it is no longer a secret that the knowledge economy revolves around a new stock of capital. Capital that is the product of knowledge creation capital that is itself part of the technological mix for other knowledge products, and capital flows that are essentially knowledge transfers. These stylized facts take on a new twist in this presentation as knowledge is conceived as codified rules. For these rules to propagate they need to be embodied and to be encoded. Or the idea of being and becoming. So that competitiveness is understood as the prevalent economic order established when an optimal set of codified rules are operated upon for a given economic, business condition under analysis. The modeling and operationalization challenge is one I would term a characterization. I chose to describe it as a characterization because of the reification that is taking place in such simulations. The emergent destination personifies its constituent spatial elements. I focus on spatial economic characterizations with attributes that becomes clearer through the use of a contagion metaphor. In a contagion, the main mechanisms are the viral load, the carrier and the rate of infection. Other relevant elements are the degree of immunity and susceptibility, which provides in a gist the ecology of the contagion. Our specific consideration is the spread of tourism through a contagion mechanism where the cumulative product of this process is an algorithmic destination. This research design is influenced heavily by evolutionary economics and Austrian economics, where rules, knowledge and economic order are intimately intertwined. Past efforts to grow economies through such a setup have been called agent-based computational economics, ACE. Some have even gone so far as to ponder whether Friedrich Hayek's economic program was a precursor to the present-day ACE. Taking such a paradigmatic stance, the growth that is associated with competitiveness is part of a trajectory of change. To analyze this trajectory, we need to trace out what conditions are initialized in its wake and where is the growth trajectory headed. There is therefore a need to determine a state of being while simultaneously considering the process of becoming. For instance, competitiveness is a state of being that is distinct from the process of becoming that is part of entrepreneurship. Though competitiveness is the cumulative result of entrepreneurship. The notion of evolution from one state to another or transition from one phase to another may be set within a famous definition of economics given by Lionel Robbins. Economics is a science which studies human behavior as a relationship between ends and scarce means which have alternative uses. One may take ends to stand for being and means to connote becoming. Economic orders are tied to their rule orders. This notion is due to Dopfer and Potts, 2008, in their general theory of economic evolution. Economic orders follow the typology of macro, meso and micro. And their corresponding rule orders are operational, mechanism and constitutional rules. Both for purposes of initializing the simulation and for the analysis of rules later. Rules are categorized according to object or subject rules. Such a categorization is also consistent with the being-becoming dichotomy. Object rules are parameters in the simulation such as, the size of the simulated population, that is the number of agents and the destination space, the initial density of tourists within the population of agents, the time threshold for susceptibility to tourism contagion and the number of iterations. These serve to capture the main gist of the conjecture's stylized facts derived from the conceptual model, providing a starting point for the generative scheme of the simulation and an ending point for the appraisal of the state of affairs in the simulation. In other words, these are rules determining destination structure. To capture the emergent process or the growth trajectory of the destination, we need to consider the subject rules. Rules that embody the propositions and hypotheses we are investigating. Going back to our contagion model for tourist destination growth, it would be the rules for conversion from non-tourists to tourist, from the mundane to the travel experience, from public spaces to tourist zones. And since this conversion progresses by degrees, the subjective rules tend to operate through recursion with additive and degenerative effects implemented as positive and negative feedback loops. The final stage of the simulation implementation boils down to a function definition for the tourism contagion in Mathematica code. The latest version of Mathematica and the Wolfram language has a built-in function called cellular automaton that dispenses with the need for customized function definitions.